So in the previous class we have seen what is macroprocessor. Macroprocessor, which is a system software which takes the source program which is having macros, and it is going to expand these macro calls, and the expanded code it is going to give it to the. So this is what we have seen in the previous. And also we have seen there are two macros which we have defined in this program is read buffer, and read buffer, the label, the macro which is having the label read buffer, and followed by a macro followed by the parameters which are there for this macro. And this macro definition, the read buffer macro definition starts with a macro and ends with mn, that is line number 9. Similarly, another macro we have defined, that is write buffer, starts with macro and ends at line number 160. And then we are going to have the main program, which consists of these macros which are called in this main program. So in this case, read buffer at line number 190, this read buffer was called with the argument f1, buffer and length. These are the actual arguments, like how in C language we have the actual parameters which are going to pass in the function call. Similarly here also these are the actual arguments. Okay, so the f1, buffer and length, these are the actual arguments, or the actual arguments in the macro call. And we have seen this read buffer is called at this location 190, and another macro which is called write buffer at 210th location. And then we have at 220 another macro is called, that is write buffer with the argument 05, EOF and 3. These are the actual arguments which are embedded in the macro calls. So with this example, we have seen how the macros are defined, and these macros are defined in the first part of your program, source program, and wherever you are going to call in the main program, you are going to call these macros, and these macros must be, macro calls must be substituted by the set of instructions which are present in the macro definition. So that is the work of the macro processor, which substitutes the set of instructions which are present in the definition wherever the call is made for that macro. So the macro call, it is going to, wherever the macro call is there, it is going to substitute the set of instructions from that definition. That means the source program size increases. So now how this is done by the macroprocessor, we are going to see the phases, the data structure, and the implementation of this macroprocessor we are going to see in today's case. This read buffer was having the label, and that label should be changed. The label should be preceded with dot, and the set of instructions we are going to place in the expanded. Similarly, in this case, we do not have label. The write buffer is not having a label in front of in preceding with this write buffer, and that's why we have not put a dot in the label portion, because it is not having a label. So we are going to write the set of instructions which are there in this write buffer. And similarly, one more write buffer is called, which is having the label end fill, and that should be preceded with dot, because where the labels will tell you where exactly it has to go. It may be used in the program, and thereby there should not be confusion between the call and the macro call label and the macro definition label. And that's why these labels must be, if the call is having the label, that must be preceded with the dot. So in this case we have preceded with a dot, and whereas the expanded code, we are not going to have a dot that separates the labeled call and not labeled macro call. So we are going to write these expanded uh, uh, code in the call macro. So wherever the macro call is present, we are going to substitute those set of instructions in the expanded code. Let us visualize this using this diagram. We have the source program which is having a definition. strg is the name of the macro, and it consists of three statements: STRA data 1, STRB data 2, STRX, STX, you are going to have data 3, and we have the mend. So STRG is a macro which is having three instruction: STA data 1, STB data 2, STX data 3, and these are embedded in macro and mend. And the source program, in the source program, this definition is appearing in the first part of your source program, and this macro is called in two locations in the source program: strg and strg. So in the expanded code, wherever you are going to have the strg, wherever you are going to have the macro call strg, then you are going to substitute these lines which are present in this macro definition. So the expanded code is having the wherever the call is there, it is going to substitute with the set of instructions from taking from the definition of that macro. So we are going to see the algorithm, macro processor algorithm, and what is the data structure which is required for this macro processor. So in this case, we are going to have two passes for the macro processor. So the first pass, which defines all the macros which are present in this source program, and in the second pass, it is going to expand the macro calls in the second pass. So the first pass is to recognize the macro definitions, and in the second pass it is going to expand the macro calls. So that is about the macro processor, which requires two passes. Now let us take an example here, macro S. So if you have let us consider for SIC machine, we can have a macro. You can have a macro defined in a macro. So we can say, let us consider a macro defined in a macro. The name of the macro is, say, macro S. We are corresponding to the SIC machine architecture. So yeah, macro S is the name of the macro, and it consists of two more macros embedded in that. One is read buffer, another one is write buffer. So read buffer starts with the macro, ends with the emend, and then write buffer starts with macro, and then it ends with emend. So the set of instructions which are present in those macros are represented with three dots. It may have any set of instructions in this macro definition. Similarly, we have three more dots after this line number 5 indicates that this macro S, which will have some more instructions which is not corresponding to particularly to read F or write F. It has some additional instructions in this macro S. So we can define a macro for SIC version, as well as a macro for SIC XC version. Then this macro should be the name of the macro should be embedded with the X symbol, macro X, which tells that it is a SIC XC version. And similarly, we can have the macro definitions which are written in this macro X. There are two macro definitions which are embedded in this macro X, along with some more instructions starting from location after the location 5. Now we are going to have we are going to see the algorithm for macro processor. So in this case, we are going to see one pass macro processor. So one pass microprocessor, which is in one pass only, it is going to define the macro as well as it is going to expand the macro calls in one pass only. So we are going to see how the data structure which is required for this macro processor, one pass macro processor, or any. So the macro names. Now when we say that the macros are defined, these macro names must be stored in a table, a separate table called name tab. So name tab, which consists of all the macros which are defined in the source program, and this name tab is having, this is a table, name tab is a table which consists of the name of the macro followed by two pointers, that is the starting address and the ending address, which is defined in the defined table, which is another uh, data structure which we are going to see. And the third data structure is argument table, which is used for expansion of the macro calls or invocations. So pictorially, uh, with this diagram, this is what I would like to explain in today's class. So the macro processor has got three data structure which we are going to use in the implementation of macro processor. It consists of three tables. One is name table, which stores all the names of the names of all the macros which are there in the source program, and then it is going to store also the name tab consists of two pointers, starting address of the macro and ending address of the macro, which is pointing to end. Similarly, the defined table has got all the instructions which are present in the macro definition. So which all macro definitions we have, those must be entered into the defined table, defined table, def tag table. Okay. And the third is arg table, which has the entries, the actual parameters, as we have discussed, the actual parameters f1, buffer and length, which are the actual parameters in the macro call, those must be stored in the arg table. Thank you.